So good morning. Again we want to continue our discussion in physics. We are seeing the third unit, effects of current. Today we can continue with the Hall effect. Hall effect is also another additional syllabus for you. If a magnetic field B is applied perpendicular to the plane of the strip, any strip, control strip, the moving charges will experience a sideways force, giving rise to potential difference between the ends. Sideways force. Actually, it gives a potential difference. This effect is called Hall effect. Another thing, C and F. This C and F. The potential difference will go on increasing till the force due to its balances the force due to magnetic field. That voltage is called Hall voltage. So I take a metal like that. So we like that. We have to do the thing. This potential. So just we know the definition, there is more than force on a current carrying conductor in a magnetic field. This another final solution is very important. We wish to bother about. In order to understand, I will give the format of the thing. So I take a conductor placed in a magnetic field, current carrying conductor in a magnetic field. So not a charge, it is an entire conductor. It's a conductor in which placed in a magnetic field. What happened? Then they experiences a force, Lorentz force. We know Lorentz force BIL, that is Q into V cross B. Here BIL sin theta. BIL sin theta, that is a force. Don't forget it. What is the force on a current carrying conductor in a magnetic field? This can be derived by, very simple, the relation between the current and the drift velocity, from which you have to derive this answer, or BIL sin theta. So the direction, this is a magnitude of the force. The direction can be represented by left hand rule. The forefinger directs the magnetic induction, center finger directs the flow of current, thumb indicates the motion of a conductor or force. This is the direction of the force. B into the direction of P into the paper, like that. So into the paper, or F is equal to I into L cross B, that is BIL sin theta. So L vector, B vector, I is not a vector, so that F into I into L cross B. Torque on a current loop in a magnetic field. So just like that, in the electric field and magnetic field, we have seen what is a torque, the rotating force. NBIA sin theta, the same formula, NBIA sin theta, torque on a current loop in a magnetic field. Tau is 0, last thing, if theta is equal to 0, because sin 0, 0. NBIA sin theta, don't forget it, torque. Force BIL sin theta. If it is on torque, NBIA sin theta. When the plane of the coil is perpendicular to the field and is maximum when theta is equal to 90, that is plane of the coil is parallel to the field. So don't forget it. If theta is equal to 90, immediately we think that it is perpendicular. So this is the angle theta. This is the angle between the position of the coil and the field. When the plane of the coil is perpendicular to the field, the plane will be the difference. The plane comes here like that, the body comes like that. Then angle between these two is 0, the plane is perpendicular. Very clear? If two planes are perpendicular to each other, the coil comes in this direction, theta 0. Therefore, tau maximum NBIA. There is a torque on a current loop in a magnetic field. That is also studied like that. This is a current loop placed in a magnetic field. So, because of these forces, there are 4 forces are acting, 1 force is acting, these 2 forces are equal and opposite, getting cancels, this acting inwards, this acting outwards. One of the force BIL into distance between these two. That is called torque. That is, torque is nothing but one of the force into perpendicular distance. Perpendicular distance is 2 sin theta. The sin theta comes. What is A? Area. Because L into B. This is the length of the loop. This is the breadth of the loop. L into B will give area. So that the area comes. This derivation detailedly we have seen in our 12th standard syllabus. When you have torque A, B, C, D or P, Q, R, S. This is the direction of the current loop. Or tau maximum is equal to NBIA. Don't forget it. This is the formula. So here we have to enter this perpendicular to the field. That is when the plane of the coil is perpendicular to the field. Because the field is always acting perpendicular. This is the direction of the field. This is the direction of the field. So the angle between these two become 0 or angle between these two is 90. When theta is equal to 0, then the coil comes parallel or perpendicular. If theta is 90, the coil becomes parallel. That's you have to understand it. Immediately you cannot get to this angle. Moving coil galvanometer. In the previous lessons also I have seen told detailedly that the moving coil galvanometer. The moving coil galvanometer is an instrument used to find out the current. What is the principle of this moving coil galvanometer? Whenever the current flowing through the coil is more, the deflection is also there. Why it deflects? This is a principle. Just now we have seen the rectangular coil placed in a magnetic field experiences a torque. It has a torque. What is a torque? Torque is called rotating force. That principle may be adopted in moving coil galvanometer. A coil is placed in between the pole pieces of a magnet. When the current is passing through the coil, automatically magnetic field is produced. Therefore, it deflects. It is attached to the needle. Since it is suspended due to inertia and also elasticity, it comes to original position. So, when it turns, that is called deflecting couple. When it comes to original position, restoring couple. At the equilibrium, the restoring couple is equal to deflecting couple. That is a principle I am adopting. Deflecting torque, NBIA, just now we have seen. Restoring couple, C theta, where C is called torsional constant of the fiber in equilibrium. So, all the body has to come to original position. That is a inertia. So, torsional constant of the fiber in equilibrium. Therefore, at the equilibrium, the deflecting couple must be equal to restoring couple. NBIA is equal to C theta, from which I is equal to C by NBA theta. This C by NBA is a constant. That constant is called galvanometer constant. You have to keep your mind what is the value of K. Galvanometer constant value C is equal K is equal to C by NBA. C is a constant, torsional constant. N number of turns for a particular coil, constant. B, we are applying the magnetic field, constant. A, area of the coil also constant. So, if we substitute all the constant, we are getting one value. That value is called galvanometer constant. Therefore, I take this constant I is equal to K theta actually. I is equal to K theta. Here K is a constant. Therefore, the current directly proportional to theta. This is the principle of moving coil galvanometer. That means more current flowing through the coil, the deflection is also high. So from which the current can be calculated. These are the things you have to understand it. Very interesting. The next one, the current sensitivity. So the same moving coil galvanometer have converted into voltmeter to measure voltage. How the moving coil galvanometer converted into ammeter to measure current. Everything we have seen detailed in the previous lesson. So I directly go to current sensitivity. The current sensitivity, deflection acting on unit current is called current sensitivity. What is current sensitivity? Deflection produced when 1 ampere current is flowing, or deflection per unit current is called current density. That is NBA by C. Why? Because just now we have seen what is the value of C. C is, K is equal to C by NBA, because I is equal to C by NBA theta. This C by NBA is a constant. I already told you that. So from which I want to find out theta by I. So theta is there, this I goes on other side. So it comes on the other side, NBA by C. So that is called current sensitivity. The current, in order to increase the sensitivity of moving coil galvanometer, the capital N, the value N, number of turns, and B and A should be increased, and the torsional constant should be decreased because in the denominator value. So we have to choose the fiber which are having low C. Low C means low torsional constant. Since it comes in the denominator, automatically what happens? The answer will be increased. The answer is called current sensitivity. Similarly, voltage sensitivity also there. Theta by V. Theta by V. So since we know the current sensitivity, from which voltage sensitivity also calculated, because I is equal to V by R, this will be divided by G. That is missing here. So here also we can have the voltage sensitivity. That is, some book they are having sigma is also correct. This is called sigma I, current sensitivity. Sigma V or SV, sensitivity. Some book they are putting S or SV. That is also correct. That is NBA by C into G. What is G? G is called galvanometer resistance. If current is divided by resistance, automatically it gives voltage. So it is called voltage sensitivity. So what is current sensitivity? NBA by C. If the voltage sensitivity act, that should be I is equal to V by R. Therefore here should be divided by R. What is called R? Here resistance is nothing but galvanometer resistance. Therefore NBA by CG. So one typical question usually asked in the entrance examination, if the current sensitivity is increased, what about the voltage sensitivity? You are simply seeing this formula, the voltage sensitivity also increase. That is wrong. Because when number of turns, for example, if number of turns of the coil increases, if N increases, the current sensitivity increases. That is given in the slide. When capital N value, what is capital N? Number of turns of the coil increases, current sensitivity also increases. Am I correct? Okay. When number of turns increases, what about the resistance? The galvanometer resistance. The resistance of the coil also increases. We know the length of the resistance of the wire directly proportional to length or proportional to L. We already known, and inversely proportional to A, area. Therefore, if number of turns increases, correspondingly resistance also increases. What about in voltage sensitivity? G also there. If N value increases, G also correspondingly increases. Therefore, no change in the voltage sensitivity. Then what do you understand? If we increase the current sensitivity, it is not necessary the voltage sensitivity will be increased. Source of magnetic field. What are the magnetic field from where we are getting? Worcester, the scientist, first we have to thankful to Worcester, observed that the magnetic field is associated with an electric current. The moving charges that creates that field. What is the thing? Whenever there is a current flowing through the coil, or whenever there is a electric field, it is always surrounded by magnetic field. This was given by the scientist Worcester. It is everyone, it is easy to produce magnetic field. Magnetic field due to moving charges. So I want to find out when the charge is on motion or current. Then current means the rate of flow of charge will give current. The charge should be flow in a particular direction. If the charge is flowing, how much magnetic field it is created? The field B due to a charge Q moving with a velocity V at any point P at a distance R from the charge Q. D is equal to mu naught by 4 pi Q into V cross R by R squared. This is R means unit vector. So this may be multiplied by R cap, let it be. A V cross R, because A cross B by modulus of A cross B. We know the unit vector. So V cross unit vector divided by R square, where R cap, not like that, this can be also cap. R cap unit vector from Q to P. The magnitude of the field, this is both the vector algebra. So the magnitude of the field, magnetic induction, V is equal to mu naught by 4 pi, because because a cross product QV sin theta by R square. So you have to keep your mind what is a magnetic field due to a moving charge. So calculate the magnetic field due to a moving charge. How can you find out? We can directly substitute with the formula V is equal to mu naught by 4 pi QV sin theta by R square. Mu naught by 4 pi QV sin theta by R square. Don't forget this formula. The direction is perpendicular to the plane containing V and R, given by the right hand screw rule. Always the direction. When which the thumb moves, that is the direction. So magnitude, just like we have seen, direction given by screw rule. Then magnetic field due to a current element. The magnetic field due to a current element can be explained by Biot-Savart law. Biot-Savart law. So with the knowing of Biot-Savart law, we can understand what is a magnetic field due to a straight conductor carrying current, what is a magnetic field due to a circular coil carrying current, what is the axis of circular coil, whatever may be the thing, in all magnetic field, and then magnetic force. This is a procedure. We should not confuse with the magnetic field. So the Biot-Savart law, so I consider any field like that, I consider a small element AB. If current flowing through the coil is I, so this element is called current element, that is DL. If I consider a point, so whenever the current flowing through a element, automatically it is surrounded by magnetic field. Within the magnetic field, I consider the point P, which is at a distance R from the center of the element. Automatically, then the magnetic induction produced is always equal to mu naught by 4 pi. Or proportional, I have to remove the proportional sign with a constant mu naught by 4 pi. It is IDL. IDL is current element. Current flowing through the conductor I. DL is the length of the conductor. IDL sin theta and inversely proportional to R square. So this is the angle theta. The angle theta means angle between the direction of the current and the current loop OP. That is called theta. So if theta value increases, magnetic field also increases. The current flowing through the element also increases, that also directly proportional. Whereas the distance of the point we are considering inside the magnetic field decreases, the magnetic field increases, or distance increases, the magnetic field produced decreases. This law is called Biot-Savart law. So why I am saying this Biot-Savart law, dB is equal to mu naught by 4 pi IDL sin theta by R square. So this is the theta value. There is a direction of the current and we are considering the point P. This distance is R. Then dB is equal to mu naught by 4 pi IDL sin theta by R square. Don't forget it. Wherever we are going to find the magnetic field due to a straight conductor or circular coil carrying conductor, whatever may be the thing, we have to compare with Biot-Savart law only. If theta is equal to 0, sin 0, 0, therefore no magnetic field is produced. Theta is equal to 90, sin 90, maximum value, therefore the magnetic field produced maximum. Magnetic field due to a straight wire, just now we have seen. The straight wire, you have to imagine, the straight wire carrying conductor, mu naught 4 by I by R into sin theta 1 by sin theta 2. What is happening here? This is also very important bookwork as far as your third standard examination is concerned. This is a straight wire, I consider. This is a point P, which is at a distance R. So in this thing, I have to consider the current element, so that we know the formula, everything. So if it is go on the other side, this is also going on other side. Therefore, I have to find the current element. So this is for phi 1, this is for phi 2. That is given theta 1 and theta 2, or sin phi 1 plus phi 2. That is better, I think so. That is the angle. What happened? Mu naught by 4 pi I by r into sin phi 1 plus sin phi 2 for a infinitely long wire. So what happened? If it goes like that, it becomes like that. Therefore, phi 1 become 90 degree, phi 2 also 90 degree. Therefore, phi 1 is equal to phi 2 is equal to pi by 2. That is equal to 90 degree. For sin 90, what is the value? This also we can change as phi 1. This also changes phi 2. Sin phi 1 plus sin phi 2. For infinite long conductor, so it goes like that. So this phi 1 value also increases, the maximum value 90. Phi 1 is equal to 90, phi 2 is equal to 90. We know sin phi 1 is equal to sin phi 2, 1 plus 1. Therefore, 2 into mu naught by 4 pi IR. This 2 getting cancels. Mu naught I by 2 pi R. This is a important formula. You have to keep your mind. What is the magnetic field? Due to a infinite, long, straight conductor carrying current. The problem is asked, you have to use this formula. B is equal to mu naught I by 2 pi R. That is the thing we have to understand it. Sometimes what is the magnetizing field is also asked. If H is asked, what happen? We know mu is equal to BH. Therefore, H is equal to B by mu. So, the answer becomes simply I by 2 pi R. Without mu naught, the answer is H. With mu naught, the answer is B. What is called B? In the first year itself, we have discussed clearly that magnetic field B, H is called magnetizing field. The magnetizing field mu is equal to BH. There is a formula we know. Mu naught I by 2 pi R. Without mu, we can calculate. With mu, B value. What is a magnetic field? Due to a circular loop. It is a straight conductor. That may be circular loop. Mu naught capital Ni by 2R. So without pi, we can calculate. That is called mu naught Ni by 2R. That is a circular loop where N is the number of turns. I, current flowing through the loop, 2R. So without a pi, the answer is circular loop. With pi, B. Therefore, mu naught I by 2 pi R, B. Mu naught Ni by 2R. Instead of I, we can put capital Ni. Capital N is number of turns. That is the value. So we have to keep the values in our mind. So, if in the coil, the circular loop, if the current is flowing clockwise direction, the current is flowing anti-clockwise direction. We know it is a clockwise direction, it is anti-clockwise direction. If the current is flowing anti-clockwise, be outwards. The direction of magnetic field produced outwards. If the current flowing clockwise direction, be inverse. So that is the thing we have to understand. We can able to find out what is the magnetic induction at any point on the axis of the loop. I have considered a circular loop. This is the axis. So I consider a point P x from O. What is the magnetic induction at P? The value V is equal to mu naught Ni R square by 2 into R square plus S square whole power 3 by 2, where R is the radius of the coil. So this is a derivation also. By using Bayes-Savart law, we can able to find out this equation. So you need not waste to derive it. Everyone might have studied in the 12th standard portion, the application of Bayes-Savart law. So therefore, the final solution we have to give there mu naught Ni by 2R, circular loop. Mu naught I by 2 pi R, straight conductor carrying current. Mu naught Ni R square by 2 into R square plus S square whole to the power of 3 by 2 will give P. How it come whole, so we have to connect this, that's all. This is a connection, this is a distance now. What happened? This is X, this is R means, what about this value? This value is root of R square plus X square. Like that we have to put. Therefore, B is equal to mu naught by 4 pi 2 ni a by r square plus s square whole power 3 by 2. So if I put 4 pi, that is I have to multiply numerator and denominator by 2. What happened? 2 by 2. These 2 become 4. Therefore, mu naught by 4 pi 2 ni a by r square plus s square. Why I put this derivation? Just previous value I can put. Because b is equal to, simply just now we have seen mu naught ni by 2r. So that is similarly you have to do mu naught ni instead of r square. Here r square plus s square whole power 3 by 2. So from that equation I take like that. So I have to formulate in an actual value that should be multiplied by 2 means that is mu naught here also multiplied by 2 4 pi. So we are getting the answer. That is mu naught by 4 pi 2 ni a by r square plus s square whole power 3 by 2. So a is equal to pi r square. We know area pi r square. For x very much greater than r, this distance is very much longer than radius. This radius can be neglected. Therefore, mu naught by 4 pi 2 ni a by x square. Because r square neglected, x square whole power 3 by 2 from x cube. This is an important formula. Mu naught by 4 pi 2 ni a by x cube. That is the thing we have to understand it. There is a magnetic field due to a circulating charge. So here charge may be circulating. What happened? Circulating charge, a current loop. So the lessons we have to understand, everything is the same. The wire is in a straight form, we call it as wire. If the wire is wound like that, we can get it is a coil. In the coil, if current is flowing, solenoid. The coil itself wound like that, through which current is flowing, toroid. Everything is same. Circulating charge, a current loop. If a particle of charge Q is revolving in a circle with a frequency nu, then the effective current I is equal to QV square. A particle of charge Q is revolving in a circle with a frequency nu, then the effective current I is equal to Q into V square. V is the velocity of the particle. Why about we know I is equal to dq by dt. dq by dt. The 1 by time will give frequency. Therefore, frequency square. Magnetic field due to it at the center of the coil, mu naught I by 2r. Just now we have seen what is the formula. That is mu naught by 2r common. I can be replaced by qv square. V speed or radius. That is qv. It is not a square. There is a small correction. We can make here. I is not v square. It is q into v. Q into v. That will give the current. Magnetic field due to it at the center of the coil, V is equal to mu naught I by 2r. Therefore, mu naught by 2r I can be replaced by qv. V speed or radius. We know the frequency. Frequency, whenever we know the time period. Time is equal to velocity is equal to distance by time. Therefore, time is equal to velocity is equal to distance by time. Therefore, time is equal to displacement by velocity. So, for one revolution, it becomes the total distance traveled is 2 pi r by v. So, this is the time period. But frequency 1 by t is called frequency. That is nu. Therefore, v by 2 pi r. Therefore, b is equal to mu naught qv by 4 pi r square. So, here we can replace the value. The radius r, nu is equal to v by 2 pi r. Therefore, v can be replaced. What is a v? That is 2 pi r. That is 2 into 2, 4 pi r into r square. Instead of v, I can put the value V by 4 pi R square, because already V will be there. That can be replaced by nu. That is the thing we have to understand. What is nu? Nu is V by 2 pi R. So here V by 2 pi R will be there. So here V will be there by 2 pi R. That can be replaced by 2 pi R. If I into 2 pi R, I have to put 2 pi R. That is 4 pi R square. That will give us nu. This is the new formula for current carrying loop, the circle. Field due to a long solenoid. That is also repeated problem. Long solenoid. The long solenoid actually looks like a rectangular coil. That's all. That is the imagination we know. The long solenoid. Long solenoid like that. What happened? That can be looks like a rectangular coil. The coil were towards the direction and outside. So it looks like a long solenoid. If I consider a rectangular loop in a particular production, so we know the magnetic flux due to the outside of the solenoid is always 0. There are about 4 integral. Remember, having in our regular syllabus, there are 4 integral. The 2 integral value are equal to 0. So here also 0, here also 0. What is the reason? Because perpendicular. Because cos 90, 0. Therefore, B is equal to mu naught Ni. So what is the formula for field due to a long solenoid? Mu naught Ni. Small n I have given. Small n is called number of turns. At one end, inside, mu naught Ni. At any one of the end, mu naught Ni by 2. So we have to divide by 2. It is the inside. What is the magnetic field due to a long solenoid? The problem is asked inside the solenoid. We have to use the formula mu naught Ni. At any one of the end, if the question is asked, that should be divided by 2. Field inside a toroidal solenoid. Mu naught Ni. Toroid, just now I said, the solenoid wound like that. That is called toroid. The toroid B is equal to mu naught Ni, the same formula. B is independent of R. That is the thing we have to understand is this field due to long solenoid. Mu naught Ni, don't forget it. Then Ampere's law, or otherwise that is also called as Ampere circuital law. So in our book it is also called Ampere's law or Ampere circuital law. It is also called as Ampere circuital law. The line integral of magnetic field around a closed loop is mu naught times the total current passing through this loop. So here the Ampere circuital law can be stated, it can be defined because it is a product. It is nothing but mu naught and A. This integral over here closed surface. This is a line integral B dot dl, because dl is the length, that is equal to mu naught into I. Integral of B dot dl is equal to mu naught I. That is the line integral is nothing but the value of product of mu naught and I. What is mu naught? We know permeability for free space. This law also you have to keep your mind. Force between two parallel current elements. So this is also derivation in our book. So what is the force between two parallel current elements? Two parallel current elements means I consider the parallel lines. Distance between these two lines are R. If current flowing through the conductor A is I1, current flowing through the conductor B is I2. So whenever the current flowing through the conductor 1 produces a magnetic field on other coil or other wire, the current flowing this wire produces a magnetic field on other side. Are you able to follow? There are two forces. Therefore, F1 and F2. Since there are two forces, mu naught by 4 pi, I1, I2, dl1, dl2 by R square. Where dl1, the length of the first conductor, dl2, length of the second conductor. R is the distance between the two parallel conductors. Long straight parallel current carrying conductor. Element, what is a long conductor? If it is infinitely long, mu naught, I1, I2, L by 2 pi r. That can be replaced by 2 pi r because L, that is mu naught I1 I2 L by 2 pi r. This is a formula. The final solution I have given. If we go to derivation, what happened? This is a force acting is like that. Here forcing acting outwards. So these are the thing. If the two parallel wires are having the direction of the current is the same, then they are having attractive force. If the direction of the current in the opposite direction, they have a repulsive force. That is also entrance question, neat question. In the two parallel wire, if the current flowing through the two long wire are in the same direction, then they experiences attractive force because two coils comes close together. If the current is in the opposite direction, they repel each other. If I1 is equal to I2, the current flowing through the first coil also 1 ampere, the current flowing through the second coil also 1 ampere. Then I1 is equal to I2 is equal to 1, and the distance between the two coil also 1 meter. So then what happen? This is also 1. Mu naught we know 4 pi into 10 power minus 7. Therefore 2 into 10 power minus 7 Newton. So when the two parallel wires through which the current flowing through the conductor of two coils separated by 1 meter distance and the current flowing through them is also 1 ampere, then force developed is 2 into 10 power minus 7 Newton. That is called 1 ampere. So this completes actually the magnetic effect of current. So we will solve some problems in this. It is also very important for our discussion. The first problem, two electrical bulbs having resistances in the ratio 1:X are connected in series parallel across a constant voltage source. Find the ratio of the powers. That is also we have seen. This is two resistors. 1:X. This one, another is X. It is connected to a source. What is the power ratio? Very simple, we know. How? When the resistors are connected in series connection, the current will be the same. Therefore, power formula I squared R, we already know. For first one, P1 is equal to I squared R1. What about P2? Simply I squared R2. Therefore, power ratio P1 by P2 is equal to R1 by R2. In this case, 1 by X is the answer. If they are connected in parallel, what will happen? So this is a parallel connection. Here also it is connected by a battery power source. What happened here? When the resistor 1 and X, if they are connected in parallel, what happened? Because it has common terminal, the potential difference will be the same. Therefore, power formula in terms of potential difference, V squared by R. For first one, V squared by R1. For second one, V squared by R2. Therefore, P1 by P2 is equal to R2 by R1. That is X by 1. That is equal to X. So this is answer. Sorry, clear this problem, important problem. We already in the first class itself, we have discussed about the power. Power, what is work done? Work done is nothing but V into Q. Q is modified by I into T. Therefore, VIT. This is the energy or work done. This work done can be modified as I square R into T or V by R square into T. What is the heat produced? And some amount of heat is dissipated as heat energy. 1 calorie is equal to 4.2 joule. Therefore, everything divided by 4.2, the first class itself, we have seen. What is the next problem number 2? 3 equal resistors connected in series across a source of EMF together dissipated 10 watt power. What would be the power dissipated if the same in series? That is also the question asked. The first one, equivalent resistor in series. The three resistor connected in series means equivalent resistor. We got to add R plus R plus R, or R1 plus R2 plus R. Therefore, 3R. Therefore, we know power is equal to V squared by R. That is V squared by 3R is equal to 10. This is a problem given. Source of EMF together dissipated 10 watt power. What would be the power dissipated if the same in series? In series, across a source of EMF together dissipated 10 watt power, what would be the power dissipated if the same in series? It is a parallel. What are be the thing? Reverse is the problem now. One is series, another is parallel. The question is asked in series, 10 watts series. What is the power dissipated in parallel? Let it be. The second one in parallel. The question is asked in parallel. So, we have to modify what is the same in parallel. There is a correct value, not series, parallel. For parallel, the total resistance R by 3. Why it is R by 3? 1 by R1 plus 1 by R2 plus 1 by R3. Therefore, 1 by R plus 1 by R plus 1 by R, 3 by R. Therefore, R by 3. This is a resistance. Therefore, power is equal to V squared by R. R means R comes, 3 goes there. This is an equation number 2. So, comparing these two equations, we can able to find out R dividing equation 1 by 2, power can be calculated. R P by 10. So, keeping P by 10, this R getting cancels. 3 getting cancels. Why there is P by 10? The right hand side, 3 V squared by R into 3R by V squared. So, V squared getting cancels. R getting cancelled. That is equal to 9. Therefore, power is equal to 9 into 10, 90 watts. When they are connected in series, the effective power is 10 watts. If they are connected in parallel, the effective voltage is 90 watts. Kindly make the correction. Here it is not series, it is parallel. Okay, that is also possible. Now to go to the third problem. Also, the EMF of a copper ferrous thermocouple varies with the temperature T of the hot junction, the cold junction being at 10 degrees centigrade as V in microvolt, 14T minus 0.02 T second. Determine the neutral and inversion temperature. This also we have seen clearly that the voltage V is equal to alpha T plus half beta T square. That is a formula I have given. Nothing. Here, compare this equation. Alpha is equal to 14 microvolt. Beta is equal to beta value minus 0.042. So here half value, half beta means that should be multiplied by 2. That is equal to 0.04 minus 0.04. Then neutral temperature, I have given the formula is minus alpha by beta. That is equal to 14 by 0.04. That is equal to 350 degrees centigrade. That is 14 divided by 4. That is 350 degrees centigrade. We know inversion temperature is nothing but 2 times neutral temperature minus Tc. That is 700 minus, if the temperature of the gold junction 10 degree, 700 minus 10, that is equal to 690 degrees centigrade. So like that the problem is asked. So remaining problem we will see in the next classes. And there are different things. Here we are solving the three problems here. One is for power dissipation in the first topic. The second one is called thermoelectricity. And what is magnetic effect we will see in the next class. Thank you.